Alright, welcome back. So, this particular module like I said in the last module, if you have seen the inverting, non-inverting amplifier and then voltage follower, input output voltage ranges, this particular module is focused on important function of an operational amplifier, and that is summing. So, like I said, operational, right, several operations can be performed by this operational amplifier, that is your op amp, right. You can use this op amp to do addition, you can use this op amp to do subtraction, you can use this op amp to integrate, so integrator, you can use this op amp to differentiator, that means it can perform mathematical functions, right, and that is why it is operational amplifier. So, we have seen this again in the theory, but let us quickly recall what exactly summing amplifier is and how we can perform an experiment using a summing amplifier, right. So, let us go on the screen, let us see what is the summing amplifier. So, if you see this particular circuit, right, the circuit is if I remove this thing, which I remove only one, if I just keep one signal which is here, and if I remove this thing, what will be it? It will be an inverting amplifier, right. The inverting amplifier is, so I do not consider this thing, right. If I do not consider this, then what will I have? I have input and I have feedback resistor R in Rf. So, V out would be Vo will be minus Rf upon R1 into V in. This is the formula for your inverting amplifier, correct. Now, if I give inputs like this, right, and if I use Kirchhoff current law, right, all of you should learn what is Kirchhoff voltage law, what is Kirchhoff current law, right. So, it is easy when I use this terminology, Kirchhoff current law, alright. I have told you the same thing in theory class also, that you do learn Kirchhoff current law and Kirchhoff voltage law. So, if I apply this Kirchhoff current law or KCL, what we will get? We will get I1 plus I2 plus I3 here minus I4 minus 0 equals to 0, correct. If you see this, I1 plus I2 plus I3 minus I4 minus 0 equals to 0. So, output voltage, right, I is what? I equals to, so we know, right, V equals to IR. So, what will be I equals to V by R, right, we all know Ohm's law, right, our favorite. So, it will be very few people who will say I do not know Ohm's law. So, using the Ohm's law, what we have? Instead of I1 we can write V1 by R1, you see the first term V1 by R1, I2 V2 by I2, I3 V3 by R3, right. So, output voltage if I convert like this, we will have Vo equals to minus Rf V1 by R1, V2 by R2, V3 by R3, and the addition of this. This we have already seen in the summer amplifier or summing amplifier, right, or it is also called summer, in short form it is called summer. So, an operation amplifier circuit which is shown here, right, it produces an output proportional to the sum of input voltages, an application of inverting amplifier, right, inverting we have already seen, op amp input is the summing junction, right, this is the input terminal, right, summing junction, useful for combining multiple inputs. We can see there are 1, 2, 3 different inputs, we can combine the multiple inputs and we can use it. The output voltage expression is as shown aside, which is here, this is the output voltage expression, right, and it can be generalized to multiple inputs by adding more voltage sources to the inverting terminal. If I keep on adding this, I can keep on adding until a particular voltage which is called Vn, right, n times, then you can add n number of input signals to the summer. This is the role of a summing amplifier. In short, the summing amplifier is used to sum the signal, sum the input voltages, and it also depends on the feedback resistor. You see there is a feedback resistor, that means it is not just summer, it is not just summing your input voltage, but it is also amplifying it, right. That is why we do not only say it is a summing, we also call it summing amplifier, alright. So, this is the use of the operational amplifier as an summer. So, let us see in an experiment how we can use this summer and how we can see the changes, how we can understand when we apply input signal, how the output signal would be obtained using the oscilloscope. So, for performing the summing amplifier or performing the summing operation, right, we have taken here an example of 2 voltages, right. There we have seen in the last slide 3 voltages, here we have taken example of 2 voltages. Now, we have a gain, you see gain, both resistance are same 1 kilo ohm 1 kilo ohm, gain will be about 2.2 kilo ohms, right, because it is RF by R1. Around 2.2 kilo ohms. Now, you have voltage here V out equals to, formula is very easy, minus RF, right, and here is I1 I2, I1 is V1 by R1, I2 is V2 by R2. So, V out equals to minus RF in the bracket V1 plus R1 plus V2 by R2. This is so simple, right. So, what we have to do if you want to perform summing amplification, we have to first connect the circuit as shown in figure, right. Second is we apply 1 volt DC to V1, 2 volts DC to V2, means we have 2 signal, we will apply 1 volts or 2 volts or 0.5 volts and 1 volt, does not matter, right. Whatever signals we are applying, corresponding to that we have to add it and we have to amplify it depending on the amplification factor, that is how the summing amplifier would work. So, observe the output and note down the value in the table. Table is here, we have value V1, voltage V2, output voltage formula is here, which is your theoretical output. So, we calculate theoretical output formula is same which is given here, right. V out equals to minus RF into V1 by R1 plus V2 by R2. We will see what is the actual output, and that will be the end of the understanding the summing amplifier. So, let us see how summing amplifier we can perform this particular operation. If you see this circuit again, which is the breadboard here on the table, and again Suman is with us to help us. So, this is a breadboard, right, and we have the summing amplifier already connected somewhere here. So, if you can see here, right, this is the summing amplifier, this is the summing amplifier which is connected here, alright. Now, if I am yes, this is better even. So, what we have seen, we can see there are 3 resistors 1, 2 and 3, right, 1, 2, 3 resistors are there, and 1 resistor is a feedback resistor, 2 resistors are the input resistors, and we are applying the signal to the individual input. So, let us use the, let us give the signal one by one. We can see here the first signal on the frequency generator, we can see the signal that is given is how much voltage, about 0.5 volts. 0.5 volts is first signal to the summing amplifier, alright. What is the second signal that we are giving? Second signal we are giving is 1 volt, right. So, and then what is the gain? Gain is about 2.2 volts, gain is about 2.2 volts. So, now we are applying 1 volts, we are applying 0.5 volts, frequency is constant 1 kilohertz, phase is 0 degree, right. Then we, what will be the output? Output will be 1 volts, right, plus 0.5 volts, right, into the gain. So, whatever the gain is. So, if we see the output will be the sum of this plus amplification. So, let us see the output in the oscilloscope. So, if we connect the oscilloscope to the output of the summing amplifier, let us see what is the output. Yeah. So, here if you see in the oscilloscope, you will be able to see the output. Output is about 3.28 volts, right. You can see yellow color peak to peak voltage, can you please show here? So, it is easy, 3.28 volts peak to peak, right. So, that is because we have added 1 volts plus 0.5 volts plus into the gain, gain is about 2.2. So, so yeah, so that is fine. Now, we can also see, if you want to see the input and corresponding output. So, the sum of the inputs and corresponding output, that is also possible. So, if you see just what is the input voltage, right. So, we will be able to see the input voltage. What is the input voltage? We can measure the input voltage using oscilloscope. Again, when you focus the oscilloscope, you will be able to see input voltage is about 0.5 volts, that is from one channel, okay. And what is the input voltage to another from the another channel, that is through the function generator, the another channel the input voltage is about 1 volts. So, we will see. see input about 1 volts. So, we have given two input voltages V1 and V2 to the summing amplifier 1 volt and 0.5 volt, and the output we were able to see about 3.28 volts, about 3.28 volts, which you can see again here around 3.28 volts, and if you again focus you will see the same value 3.24, 3.28 volts. That means that what is my calculation, let us come on the screen. My input voltage V1 was 0.5, V2 was 1 volt, V output was 3.24 volts. Here theoretical calculation, alright, theory, V out equals to RF 2.2 into V1, what is V1, 1 volt by R1 1 plus V2 0.5 by R2 1 volts, right. So, this will be what, if I calculate this will be 2.2 into 1 plus 0.5 or 1.5 or minus 2.2 into 1.5 volts. Is it correct? So, this will be close to your 3.24 volts, right, this will be close to your 3.24 volts. You calculate this minus 2.2 into 1.5 volts, and this is how you can calculate theoretically. So, this is theoretical way of measuring the output of the summing amplifier. This is the actual way or practical way of measuring the output of the summing amplifier. Now, you guys, now you know how to use a summing amplifier, that means how to use the operational amplifier as a summer, right. It is so simple, whatever input signals you are giving, it will add it, it will sum it, right. V1, V2, V1 plus V2, V1, V2, V3, V1 plus V2 plus V3, right, but it is amplifier also, that means it will amplify with the set gain that you have set. That means that if your gain is about 2 volts or about 2, sorry, it should never be volts, okay, gain is about 2, then 2 into your sum of the input signal, very easy, right. This is how you can operate or you can use operation amplifier as a summing circuit. The same way in the following modules we will be looking at different application of the op amp. Like I said, we will see how the integrator is, we will see how the differentiator is, we will see how separator is. If you can sum it, you can also subtract it, isn't it. So, I hope that in this particular module you are able to understand how you can use operation amplifier if you have the minimum number of equipment in your lab, right. So, you just require a DC source, you require a multimeter, and it is very easy, it is a cheap multimeter, it is not so costly. That is why when I say, again this is all relative terms, for one person it may be extremely costly, for second person it can be super cheap. So, we can never say cheap or costly, but the point is that most of the laboratories would have the multimeter, most of the laboratories would have the function generator, most of the laboratories would have DC power supply, most of the laboratories would have oscilloscope, right. So, it is easy. If you cannot see the signal at the output in the oscilloscope, you can measure the output using multimeter, right. Your understanding does not really depend on you should have an oscilloscope. If you do not have it, do not worry, you have a multimeter, right. So, with a minimum number of equipment that we have in front of us, with a breadboard that we have, right, with a breadboard that we have, correct, then with a IC and few passive components which are resistors, right, with the IC and few components which are resistors and with some connectors, you can always test different operational amplifier circuits, right. So, this is the idea, that is why I am pressing more on the experiments. Even it looks very simple, when you really work on it, you will find few of the things that you never expected that it will happen, right. One thing that you have seen in earlier modules, that we gave square wave and we were expecting a sine wave. So, you cannot get that, right. When you apply sine wave, you will get sine wave. Again you can convert the signal using again op amp. So, that is another part, well I will cover it, that if you apply sine wave, can you obtain a triangle wave, or can you obtain a square wave, or if you apply square wave, can you change it to some other waves waveform. So, you can do that, that is not a problem, but the point is right now we were not working on the conversion, we were working on the input signal and the output signal. Input signal and output signal waveform would be same, only there will be change in the phase shift. So, one there was phase shift change of 0 degree in non-inverting, one it was phase shift of 180 degree, inverting we have seen input voltage ranges, and now we have seen the summing amplifier. We have also seen the voltage follower or buffer or unity gain amplifier, right. So, this is the end for this particular module, and I hope that I see you in the next class where I will be teaching more on the another application of the operation amplifier and how to operate it. Alright, you have a nice day, and I will see you in the next class. Bye.